So let's say we want to add pitch control to fix this situation. So one type of control surface we can add is called a canard. So that's at the front end of the aircraft. These can induce pitch. So if you're pitching too high, you want to decrease that, you can cause downforce on the front of the aircraft, and that will push the nose down, and the pilot could induce getting away from those oscillations that you don't want. However, in this situation, the fixed part of the wing here and all this wing is on the front of the aircraft. So if the pilot doesn't react very fast, let's say you start to pitch and the wing is producing more. We saw how the wing produces more torque to pitch up more. Well, this airfoil here, even though it's symmetric, its center of pressure is not moving very much, but its center of pressure stays at the front of the aircraft, way in front of the CG. Let's turn on the CG. So even this change in lift here, if the pilot has not reacted, induces more pitch up. So the pilot's got to be pretty quick here to control out any oscillations. So this portion of the canard actually increases the instability. So more frequently we end up with a different system for pitch stability and control, which is having it in the aft of the aircraft. So let's see that.